Dear students, warm greetings to all. In this unit, we are going to discuss on the topic of passband transmission system. So first of all, we are going to see what is a basic concept of digital signal transmission. So there are generally two types. First one is baseband data transmission, and second one is passband data transmission. What do you mean by baseband data transmission means here the digital data is transmitted over the channel directly. But in passband data transmission, the digital data will be transmitted by using the high carrier frequencies. So this is the main difference in baseband and passband. In baseband transmission, we don't perform any modulation method. So no modulation will be done here. But for passband transmission, the modulation will be done. Without modulation, we can't able to transmit the signals. In baseband data transmission, it is very well suitable for the transmission over short distance only. But for passband, we can transmit it over a long distance. So the very good examples which can be given for a baseband transmission is audio and video signals. For passband data transmission, we are going to be discussed briefly on what is ASK, what is FSK and PSK. Next thing we can see what is the basic requirements of baseband transmission scheme. What is the need? Because of going for this passband transmission scheme, what is the advantages? These are the things we are going to be discussed in this slide here. So main requirement for the passband transmission system is we can able to obtain a maximum data transmission rate, as well as we can able to obtain the minimum probability of symbol error, and we can utilize only a minimum transmitted power, as well as we can require only a minimum channel bandwidth. So here we'll be having some maximum resistance to the interfering signals. So the circuit also will be less complex. So we can say it as minimum circuit complexity here. So these are the main requirements, the reason which is make us to go for the passband transmission scheme. So this is advantages as we are discussed here. As we know that it is a long distance transmission, and here we can able to use analog channels can be used for the transmission, and we can able to perform the multiplexing techniques can be used for PMW conservation, that is bandwidth, and we can able to reduce the interference crosstalk, this interference and crosstalk, and it can be take place over the wireless channel. So the next thing is we are going to see the types of reception for passband transmission. So there are two types of methods of deduction of the passband. The first one is coherent deduction, and second one is non-coherent deduction. What do you mean by coherent deduction means the local carrier generated at the receiver will be an phase lock with the carrier at the transmitting. So we can say it as there should be a synchronization between the receiving part to the transmitting part. That is, we can say it as synchronous deduction. That is, we can call it as coherent. But in non-coherent, we can say it as the receiver carrier will not be phase locked with the transmitting carrier. So this is we can call it as non-coherent or envelope reduction. In digital modulation transmission system, data transmission system, here we can perform modulation as three types: phase shifting, frequency shifting, and amplitude shifting. So what do you mean by phase shifting means the digital data will be modulates the phase of the carrier. Here for FSK, it will be modulates the frequency. In amplitude, it will be modulates the amplitude. So in digital, in amplitude shifting, it will be modulates the input signal will be modulates the amplitude of the carrier signals. So this is a different modulation schemes: ASK, FSK, and PSK. So the combinedly we can call QAM as the combination of both ASK and PSK. So in ASK, as we see the diagram here, in ASK signal, the amplitude will be various with respect to the digital signal. So based on the value of the input signal as ones and zero, what happens means the amplitude will be changes. So for the input signal of one, we'll be having the amplitude level the same as one. Amplitude will be remains constant, but for zero we don't have the signal. So if you come across FSK, it will be the carrier signal will be changes with respect to your based on the input signal frequencies. So what happens means the carrier signal frequency will be changed with respect to one and zero. So for input signal as one, it will be operated one frequency, and for zero, it will be operated another frequencies. So that is we can call it as FSK. But for PSK, for input signal as one, it will be operated at one frequency. If for input signal as zero, it will be operated at another frequency. For example, we can say it as for one, it will be operated at 0 degree, and for zero, it will be having some phase reversal of 180 degree. So that is we can call it as PSK. So this is a comparison of what is ASK, FSK, and PSK. So based on the characteristic bandwidth, noise, humidity, probability of error, performance in noise, system complexity, and bitrate, they have been mentioned for the different types of modulation schemes here. For amplitude modulation, the bandwidth will be twice of FB. For frequency, we'll have four of FB, and phase as twice of FB here. And noise humidity will be very less in amplitude, but it will be more in the high in the frequency as well as the phase. And another category is parameter is probability of error. The probability of error will be high in your ASK signal and will be very low in your FSK and PSK. And noise also, the performance in presence of noise will be very less in your ASK. It will be better when compared to the FSK, and in PSK will perform very well. And system complexity, as we know, ASK will be very simple, and FSK will be an moderately complex, and PSK will be complex here. And the bitrate value for a ASK signal is 100 bits per second. For frequency is 1200 bits per second, and for PSK it will be higher bitrate. Next, we are going to see what is the generation of FSK. So generation method of that is in this topic we are going to cover what is generation reduction of frequency shift keying here. How we are going to generate the FSK signals, that is we can call it as frequency shift keying here. So first initially we are going to give the input sequence of data. It may be in binary, either zeros and ones. So from that it has been given to the on off level encoder, where it's going to be encoder based on the different types of encoding methods. So from that it has been given to the next section of the signal here. So where it's going to be generated, that is on off level encoder means here we are going to be, if your signal is 1, it has been given considered as m of t, and m bar of t will be considered as 0. So here we are going to provide the phase lock signal as pi 1 of t is equal to root of 2 divided by Tp cos of 2 pi f1 of t. It will be operating at one frequency, and another frequency as pi 2 of t is equal to root of 2 divided by Tb cos of 2 pi f2 of t. So after that, what happens means it is going to multiply the two signals here, and it's going to be added here, and we are going to generate the binary FSK signal. What is the concept which is happening here means, first, initially, we are going to generate in binary FSK system, we are going to generate the two symbols are transmitted. So two symbols are going to be transmitted. So symbol 1 and symbol 0. For symbol 1, we are going to be obtain the output as S1 of t is equal to root of twice of EB divided by TB cos of 2 pi F1 of t for symbol 1, and S2 of t is equal to root of twice of EB divided by TB cos 2 pi F2 of t for symbol 0 here. The next, the basic functions which is used to generate the signals can be given by the expression as pi 1 of t and pi 2 of t. So based on the two signal frequency as f1 and f2, f1 for the input signal as 1, for the f2 will be for 0. So next here we are going to expose this FSK signal is characterized by two-dimensional signal space with two message points, so which can be given by the number as n is equal to 2, as we have two message point as m is equal to 2. So we are going to express as S1 and S2. So for that, we are going to define in terms of the root of EB 0 and S2 is equal to 0 root of EB here. So which can be expressed in terms of your signal space diagram here. So before that, we can see after receiving the incoming binary data sequence is applied to on-off level encoder. The output of the encoder will be an root of EB for the symbol 1 and it will be 0 for the symbol 0. Okay, so then when we have the symbol 1, the upper channel will be switch off with the oscillator frequency of F1. For symbol second data symbol as 0 here, for that, since we have the inverter, the lower channel is switch on with the operating frequency as F2. Then these two frequencies are combined by using the adder circuit and then it has been transmitted. So this is a function which is happening in the FSK. So that can be expressed in terms of the signal space diagram here. Since as we know it is a two-dimensional two message points here which can be expressed as pi1 and pi2 which will be covering the region of our region Z1 and Z2 here. So for pi1 we'll be having as root of EB0. So we'll be having the message the message point 1 will be lies on that particular point and a message point 2 will be 0 and root of EB here. That can be expressed in your signal space diagram. So next one is it is a deduction of circuit here. So how you are going to deduct the FSK signal? So this is a block diagram which will be represent the coherent FSK detector here. It deducts whether the signal represents binary 1 or binary 0. So the received FSK signal enters the receiver here. First of all, we have been provided with the correlator. So the signal is split into two parts. The upper branch multiplies the signals with the pi1 of t. It can be act as a reference frequency for bit 1. The lower branch multiplies the signal with pi2 of t. That is, we can call it as a reference frequency for bit 0. Then the signal has been given to the integrator. Each signal is integrated over a 1 bit duration of TB. After integration here, the outputs are x1 and x2. That is, we can call it as correlation with frequency f1 and correlation with frequency f2. From that, it has been given to the subtractor where the outputs are compared. Compared by subtracting process. So we are going to get the output as y is equal to x1 minus x2. So from that, it has been given to the decision device where the threshold has been fixed as 0. If y is greater than 0, we can choose the binary input as 1. If y is lesser than 0, we can choose the binary as 0 here. So based on the decision rule here, if x1 is greater than x2, we can choose output as 1. If x2 is greater than 1, we can choose output as 0 here. So this is a basic standard coherent FSK deduction method used in digital communication systems. So next one we are going to see here, what is the probability of error calculation for the FSK here. Here we are going to provide it with the two basic function as pi1 of t and pi2 of t as we know as we have read this equation earlier. So from that we can able to express the transmitted signal as s1 of t and s2 of t as e root of eb pi1 of t and root of eb into pi2 of t for symbol 1 and symbol 0. So this is also from the two message points as we know that here. Next, from the observation vector, based on the integration here, we'll be having the two observation vector as x1 and x2. From that, it has been given to the subtraction section where we are going to find the difference of two random variable as L is equal to x1 minus x2 here. So while the symbol 0 was supposed to transmitted, x1 and x2 has a mean value of 0 and root of EB. If one is transmitted, which will be having as root of EB and 0. So based on the 1 transmission and 0 transmission here, you can able to find what is the probability of error function for the symbol 1 for transmitter and 0 has been received. So based on the condition here, we have find the probability of error for the symbol transmission 1 and received symbol as 0, and second case is transmission symbol as 0 and received case as 1. So based on the both the probability, we have obtained the probability of error function for the FSK signal is P is equal to 1 by 2 error function of root of EB divided by 2n naught.